So we have an inequality problem with us, and the interesting thing about this problem is that we can accomplish these things simply using mathematical induction. There is a version of this problem which actually is weaker. It says that show that xn is less than square root of 2n plus 1. So this one is actually a more interesting problem. To show the stronger version, that is xn is less than or equals to 1 by square root of 3n plus 1, you can realize that this is a stronger version, right? Because this is a closer bound. I mean, 1 by square root of 3n plus 1 is obviously smaller than 1 by square root of 2n plus 1. To show that xn is not only smaller than this, but it is also smaller than this, is a stronger result. We will use induction, mathematical induction, and the solution is pretty routine. There is nothing special about this induction actually. So if we look into the given expression, suppose we try it for n equals to 1. So this is the test case. For n equals to 1, xn is just 1 over 2. And 1 by square root of 3n plus 1 is simply 1 by square root of 3 times 1 plus 2 plus 1. So this is 1 by square root of 4, which is half. So of course, half is less than or equals to half, and we accomplish the test case. Now, when we have the inductive case, the inductive assumption, so we assume that it is true, assume that the result is true for n equals to some k, which basically means that if we go from 1 over 2 times 3 over 4 times 5 over 6 up to 2k minus 1 by 2k, then this is less than or equals to 1 over square root of 3k plus 1. In fact, I shouldn't even bother to write 3 over 4 or 5 over 6 because we have just checked with n equals to 1. Anyways, doesn't really matter. Now, we want to show that, that the result is true, the inequality holds. The inequality holds for n equals to k plus 1. So what is exactly that we want to show? We want to show that 1 over 2 times 3 over 4 times 5 over 6 up to 2k minus 1 over 2k times 2 times k plus 1 times, and the numerator is 2k plus 1. This is less than or equals to 1 over square root of 3 times k plus 1 times plus 1. So how do we go about doing this? Well, the method is pretty standard. We use what we know. We know this, so we replace by that. So clearly this left-hand side, the left-hand side is less than or equals to 1 over square root of 3k plus 1 times 2k plus 1 by 2k plus 2. So if we can show that this quantity that we have found is less than or equal to that which we want to show, then we would be done. Let's do that. We have 1 over square root of 3k plus 1 times 2k plus 1 over 2k plus 2. We want to show that it is less than or equals to 1 over 3k plus 4 square root. So this is a standard technique. You start with what you want to show and you end up with a true statement. Then you can say that whatever you started off with is correct. So what we do is basically we square both sides. So square both sides. Squaring both sides, we get 1 over 3k plus 1, 2k plus 1 squared by 2k plus 2 squared. We want to show that this is less than or equal to 3k plus 4. So all these steps are if and only if steps. That is, if so basically as we are coming down, after we end up in a true statement somewhere down the line, we should be able to go up from that true statement and trace it back to the original inequality that we want to show. So anyway, let's proceed. This is just brute calculation, nothing else. We will cross multiply. So we have 4k squared plus 4k plus 1 times 3k plus 4, and we want to show that this is less than or equals to, let's get rid of these arrows, 3k plus 1 times 4k squared plus 8k plus 4. So cross multiplying we get, so we open the parentheses, we get 12k cubed plus 16k squared plus 12k squared plus 16k plus 3k plus 4. We wish to show that this is less than or equals to, the right hand side is, let's use a different color, 12k cubed plus 24k squared plus 12k plus 4k squared plus 8k plus 4. Firstly, we can cancel off the 12k cubed from both sides. So we have a 28k squared on the left hand side plus 19k plus 4 is less than or equals to, we again have 28k squared on the left hand side plus 20k plus 4. So clearly these two cancels off, the 4 cancels off, we are left out with 19k is less than or equals to 20k, which is obviously true, which basically, since k is not 0, so 19 is less than or equals to 20, which is obviously a true statement. So see, since each of these steps were if and only if, we could go back and we can reach this first step, and this is our target step, right? So with using induction, we are done. So reviewing the entire process, you will see that the test case was for n equals to 1. Then we assumed the result to be true for n equals to k. Then we showed it to be true for n equals to k plus 1. Now, as an exercise, you can try to show that xn is less than or equals to square root of 2n minus 1 plus 1, this particular result that I mentioned here, and try it without induction. I mean, obviously, if the one that we proved is a stronger result, but it is just fun to prove this one.